Greetings, fellow modelers. In this video, I'll walk you through the step-by-step process of creating a Spur gear using Plasticity 3D. I'll also delve into the basics of the minimum required geometry needed to calculate for an accurate model. If you've got an alternative approach to achieve the same result, drop your suggestions in the comment section. Stay tuned for another video where I'll demonstrate the in-place 3D printing of a simple mechanism with gears. Consider subscribing to stay updated. Thanks for joining, and let's gear up for some fun. Before we jump into construction of the gear, let's talk about basic geometry we will need to calculate. So the tip diameter is the largest diameter of the gear. It represents the edge where the teeth of the gear ends. The pitch diameter is, in my opinion, the most important diameter, as we will use it to calculate everything else. The base diameter is the one from where we will have to calculate the curve that represent the shape of each tooth. So this curve is called invalid curve. It is very important, as I mentioned, to calculate it from the base. The clearance diameter is the diameter where another merged gear can reach when two gears work together. So for example, there is another gear. So another gear can never cross this and should never cross this clearance diameter. And the root diameter is the diameter that represents where the tooth actually starts. For calculation of each of these diameters, I prepared the formulas here. They match each color. So dt, diameter of the tip, dp, diameter of the pitch, and so on. M, which is the model. The model is a standard unit of measure of the gear tooth size. For example, the smaller the value of the model, the smaller teeth of the gear. The larger value of the model, larger teeth. And Z is the number of teeth of the gear. So let's get started. I will keep this diagram on the screen as a reference. We are starting by calculation of the diameter of the pitch. So I will use the model equal to, so this is a relatively small size of teeth, and the number of teeth I want to have on my gear is going to be 20. That means the diameter of the pitch is going to be 20 multiplied by 2, 40 units. I am using millimeters, so in my case this is 40 millimeters, and I will call this circle as diameter of the pitch. The next diameter is the diameter of the tip. Diameter of the tip is diameter of the pitch, which is 40, plus 2m. Since my model is 2 multiplied by 2 is 4, and plus diameter of the pitch, then the diameter of the tip is 44. The next diameter I'm going to calculate is going to be the diameter of the clearance, which is equal to diameter of pitch minus 2m. As you can see, this is the opposite calculation to diameter of the tip. So diameter of pitch is 40 minus 2m, meaning 40 minus 4 equals 36. The next diameter I'm going to calculate is going to be diameter of the root. The diameter of the root must be smaller than diameter of the clearance. As we said, the clearance is where another gear can reach, and it can never cross the diameter of the clearance. Diameter of the root is calculated by diameter of pitch minus 2 multiplied by 1.25 multiplied by m. And the reason why we add 25% to the model to add this exactly small gap between the clearance and the root. In our case, the diameter of the root is going to be 40 minus 2 multiplied by 2.5, meaning that 40 minus 5, which is 35. And I will quickly call this circles properly. So this is diameter of the root, dr, diameter of clearance, dc, diameter of the tip, dd. This is going to help us as we progress. The next diameter I'm going to calculate is going to be the diameter of the base. And as I said, this is one of the most important diameters we will use to calculate the shape of each tooth. To calculate diameter of the base, we need to multiply diameter of the pitch by cosine of, in that case, 20 degrees. Why 20 degrees? It is standard pressure angle of the spur gear. It usually varies from 15 to 20. For this tutorial, for simplicity of calculation, I'm using 20. Okay, so I'm going to bring the calculator and we will calculate. So the diameter of the pitch is 40, and we'll need to calculate it by cosine of 20. Okay, so 20, the cosine of 20 is 0.95, Okay, and I'm going to multiply this by 40. And we're going to get 380426. So I'm going to take just first 5 digits after the point. It is more than enough. So the diameter of the base, name it diameter of the base. So now we have all the main diameters we need to continue. Okay, let's group all these diameters. So from this point, we can start constructing the curve for the shape of the tooth. There are a few ways how this invalid curve can be constructed. We can build all the construction points around the entire gear to be super precise, but I don't really need it at this moment, so I will use only a quarter this circumference to calculate what we need. So in order to do that, I'll start constructing this horizontal line, and I will use a radial array to rotate it, but not around 360 degrees, but just for 90 degrees. And I don't need this many points. I don't need to be so extremely precise, so I will use just 4. Okay, so how this construction curves can help us to calculate the curve we need. The invalid curve is calculated from the points that represent each part of the circumference. So let's start from here. So in order to do it, we will need to draw a line, 90 degrees, the same thing here, and the same thing here. And what is very important is that each of these lines should be equal to the length of the part of circumference it represents. So what does it mean? This means that this basically should be unwrap of this part of the circle. This construction line should be unwrap of this part of the circle, and so on. The length of the circumference is calculated by 2 by p and by radius. So in other case, because we know the diameter, so we'll just multiply p by diameter, just 3/14 multiplied by diameter in this case. So our base diameter is 38,042. Now I'm going to bring back my calculator. So 38,042, this is diameter. We multiply by p. And this is going to give us 119,512. This value represents the length of the entire circumference, but we need only 1/4 of it. So we will divide this by 4. And we get 29,871. So this is the length of the first construction line that we need to create. Very important, 90 degrees. 28,871. The length of the next construction line should be equal to 2/3. So let's calculate that. So we know that the length of the 3/3 is 29,871. If we divide it by 3, this is 1/3, and multiplied by 2 is going to be 199187. Let's draw this line, and it must be 90 degrees to this radius. If we have here 150 and here 30, so this means that 90 degrees is going to be 120 here. And we set the length we just calculated. So the last construction line we need to build is going to be perpendicular to this radius and is going to be equal to the length of this third. We remember that the length of the quarter of the circumference is 29,871. So if we divide it by 3, this is going to be 95936. This level of precision is good enough for me. So now we can construct another line that should be perpendicular to this one. So in here I have 120 degrees and 60. So this means that it's going to be here 150. So now we have all these construction lines representing the unwrapped parts of the circumference. To construct the involute curve, we need to connect the ends of these construction curves with the spline, starting from the baseline, base diameter. So this curve, it represents the one side of the shape of the tooth. So let's name this curve, and let's put them here, involute curves. And I can hide all these curves now. I'm bringing back this diagram so we can talk a little bit about how to find the axis or curve around which we want to mirror the involute curve we just created. So I mentioned at the beginning that the gear I'm constructing has 20 teeth. 20 teeth meaning that the angle of the arc is 360 divided by 20. This means 18 degrees. Exactly the same, we can say that the angle between the ends of each tooth is going to be the same, 18 degrees. This means that the exact middle point here is going to be 80 degrees divided by 2, which is going to be 9. But our involute curve that we created is here. And we want to mirror it like that. So given that here we have 9 degrees, so we need to divide this by 2 one more time, and we're going to get 4.5. So one more time, the gear we are constructing has 20 teeth. If we distribute them evenly across the 360 degrees circle, we are going to get the angle for the arc 360 divided by 20, which means 18. This means that the angle of the arc of one tooth is 9 degrees. But our involute curve is here, and we need to mirror it to form one tooth. This means that we need to mirror it over here in the middle of the 9-degree arc, which is going to give us 4.5. Let's do it. As we calculated, the angle for the line around which we want to mirror this involute curve is 4.5 degrees. So if I construct the line all the way up, it constructed with 90 degrees to x-axis, right? From 0 to 90. So I need 90 minus 4.5. So this is our construction line around which we can mirror the involute curve now. Selecting the curve, mirror in freestyle, selecting the construction line. Okay. If we start trimming a little bit, we will see that we start getting the shape of the tooth. I am going to duplicate all the diameters we created and hide them so we can reference them later on. Shift D. And I'm going to hide original ones. So now we can start trimming the parts we don't need. The base, we don't need this anymore. We'll keep root and we will keep clearance as we still need them to construct the remaining parts. We can select this tooth we just created, and just for the sake of testing, let's use radial array and put it 20 times around the gear. And we can already see that we have a very nice consistent shape. So, but before we really place it, we still need to do a couple of more things, so we have less work to do after. So the first is that I'm going to connect the ends of the tooth with the center. This is going to give me the depth of the tooth up to the clearance circle and the root. I don't need this anymore. And I'm going to use the radial array to put the second 2's on the circle. So let's set 2, 160 divided by 20, which is number of teeth, and here we go, we have the second one. Okay, I'll continue trimming from here. So at this point, I can remove all the construction curves I do not need anymore. So I kept the root and the clearance diameters in order to create fillets, selecting these curves between which I want to create bevels, join them, and I create a bevel which is smaller. It shouldn't really go above the clearance line. As I said, the clearance diameter is the point that the merged gear may reach but cannot cross. So my bevel is going to be just a little bit below. Okay. So now removing the all other curves that we're going to just repeat with the radial array. So I don't need this, and this. Let's say OK, and so let's join this into one. With this curve selected, let's repeat it 20 times around 360 degrees, around the beginning of the coordinates, and we have the shape of the gear. Can extrude it. Let's extrude it by 8 millimeters. You can have now, let's say, the round diameter of 8 millimeters. Let's say we want to have some additional hardware to make sure that this gear sits well on the shaft. So let's create 2 by 2 millimeters square and just use it as a cutter. We have a gear.